Right now, the solid ground beneath your feet slams into a catastrophic lock. The Earth has suddenly stopped rotating, coming to an instantaneous standstill. While the solid bedrock has come to a standstill, everything else is still subject to inertia. The breathable air, the vast oceans, and every unanchored object are still traveling at the same speed the planet was just spinning. Anything not bolted down suddenly behaves like a loose passenger in a high-speed car crash. The atmosphere doesn't stop with the ground. Instead, it turns into a supersonic wall of wind, scouring the surface and leveling almost everything in its path. That wind is fueled by a momentum we rarely acknowledge. At the equator, the surface of the Earth is currently hurtling through space at roughly 1,670 kilometers per hour, about Mach 1.35. We don't feel this speed because our daily life is like riding in a smooth-flying airplane. As long as the velocity is constant, the only thing our bodies register is the downward pull of gravity. This combination of constant momentum and gravitational pull is what keeps us grounded, making the spin of the planet effectively invisible to our senses. Our perception of a stable, stationary world is an illusion. It depends entirely on the planet maintaining its pace without interruption. Because rotational speed is highest at the equator, that's where the destruction is absolute. Mach 1.35 winds would instantly flatten forests, shear away mountainsides, and obliterate every man-made structure. At the mid-latitudes, the spin is slower, so the winds are technically sub-Mach, but they are still lethal enough to level cities and displace topsoil. Only the exact north and south poles offer a chance at immediate survival. Because the rotational speed at the axis is zero, the physical impact of a sudden stop would be negligible. You might only stumble. In this scenario, your geography is your fate. Your exact distance from the equator determines whether you are launched into the air or if you simply lose your balance. The wind is only the first wave of chaos. The eastward momentum of the oceans would hurl massive volumes of water across the continents, creating tsunamis that would scour the land. As the tsunamis recede, the global map changes. Earth's rotation creates an equatorial bulge, pulling a massive ring of water outward. If the spin stops, gravity takes over. The water drains away from the equator, pooling at the poles. Within hours, the geography we know is gone. The Earth becomes a world of two polar oceans separated by a single, dry, equatorial megacontinent. While the Earth stopped its daily rotation, it hasn't stopped its yearly journey around the Sun. Without the 24-hour spin, the light cycle is dictated entirely by that orbit. A single day and night would now last an entire year. One side of the planet would be baked under relentless sunlight for 6 months, while the other hemisphere remained frozen in total, absolute darkness for the other 6. This loss of the 24-hour cycle destroys the thermal balance that regulates our weather, leading to extreme temperatures that few life forms could survive. Beneath the surface, the planet's internal systems are also failing. Without rotation, the dynamo effect in Earth's molten core begins to slow down. As that engine stalls, our magnetic field decays, leaving us vulnerable to solar radiation. Shifting masses in the core would also trigger global earthquakes and volcanic eruptions. For any survivors, life would be confined to the Terminator Zone, the narrow strip of perpetual twilight between the scorched dayside and the frozen night. Humans would have to follow this narrow strip as it moves around the sun once a year, or retreat deep underground to rely on geothermal heat. The violent physical halt is only the first hurdle. What follows is a permanent struggle to survive on a planet where the basic systems of habitability have failed. While a sudden stop is a thought experiment, the Earth's rotation is actually slowing down right now, gradually decelerated by the tidal friction of the Moon. History shows us the potential consequences. Around 250 million years ago, a dramatic slowing of the Earth's rotation coincided with the Permian-Triassic extinction. Researchers believe this deceleration altered ocean circulation and chemistry, destabilizing the marine environments that supported the vast majority of life. By the time it was over, the Great Dying had wiped out 90% of all species. Modern observations are catching similar signals. Seismic data confirms that Earth's inner core has been rotating noticeably slower since 2010. We treat the 24-hour day as a constant, but it is a precisely tuned cycle that regulates our climate, our oceans, and our biological rhythms. If the spin of our planet is what dictates our survival, what happens when the clock finally runs out?